continuing with the theme of oceans and coastlines here, this lecture is going to be about ocean circulation. Just to remind you, so the lecture that you should have just been watching would have been about ocean chemistry. So we talked about ocean salinity and ocean temperature. So this one's going to be about ocean currents. So we're going to talk about things called gyres here in a second. We'll talk about shallow ocean circulation, and then we'll make a brief mention about deep ocean water circulation. So let's talk about why ocean water circulates. So there's an important reason for caring, or there is a reason you should care about ocean water circulation, and that is because all of our weather systems are driven by ocean water, or many of our weather systems are driven by ocean water circulation. So ocean water circulation is literally what creates climate and weather patterns in given regions. So it's important to understand why ocean water circulates. So let's talk about why it actually circulates. So first, the exosphere, which is just outer space, the sun hits the equator most directly. So if the sun hits the equator most directly, it's going to heat up the equator the most, but water likes to be in equilibrium. It likes to be the same temperature. So if you have the sun and it hits the equator most directly, that water is going to start to move because it wants to move to become an equal temperature with the water around it, which would be cooler. So it's going to start to move just in response to this difference in temperature between the equator water and then like the North Pole or the South Pole. So that's one reason why ocean water circulates. The atmosphere also affects it. So we'll talk about wind speed and wind in the next lecture, but the spinning of Earth generates currents and it generates waves. And then in atmospheric conditions, as atmospheric winds are blowing, that can create waves and currents on the surface. So we have the exosphere, outer space, we got the atmosphere. Lastly, we have the geosphere. So the fact that we have land masses, they are obstacles to ocean circulation. So instead of ocean water being able to just circle the globe over and over and over, it has obstacles. So those obstacles deflect those currents in a certain direction, given if it's in the northern or the southern hemisphere, it differs a little bit. But they deflect ocean currents, so they create kind of these curved rotation patterns that we see in the ocean, and we call those gyres, which that's written down here for you, Gyres. So we're just talking about shallow ocean circulation here. We're going to talk about deep ocean circulation shortly in a couple minutes. So simplified, shallow ocean currents, if warm water is found at the equator where the sun hits the equator most directly, warm ocean surface water that's heated at the equator starts to move, and it will move towards the North Pole or the South Pole. So we can illustrate that this way with kind of the red arrows correspond to warm temperatures close to the equator. And as that water flows towards the North Pole or towards the South Pole, it's going to cool off. It will become cold water. And then we have these blue arrows here that indicate to us that this is cold water that comes from either the North or the South Pole. So this is a simplified view of ocean currents, shallow ocean currents, but let's add some more detail. Just to give you an example, our local shallow ocean current is the Gulf Stream. So if you've heard of the Gulf Stream before, basically it's kind of this area of flow that goes up the East Coast, and that's what distributes warm water from down in Florida or the Caribbean up the East Coast. So that's our local shallow ocean current. So we call each of these gyres, and again, every ocean has its own gyre. So there's the North Pacific gyre, there's the South Pacific gyre, there's the South Indian gyre, there is the South Atlantic gyre, and then the North Atlantic gyre. So every ocean kind of has its own gyre, but it's also divided by the northern and the southern hemisphere. These are driven by the prevailing wind directions, and then the geosphere, how land is an obstacle and it deflects ocean currents. So your first quiz question for this lecture is, what do you notice about the direction that gyres rotate in the northern hemisphere compared to the southern hemisphere based on the map that you have here in front of you? And then come back when you're ready. Second question. So you have a shipment of rubber ducks. Let's say that shipment of rubber ducks falls overboard in the northern Pacific at location A. So based on what you just observed on the last question, what path do the ducks subsequently follow if they fall overboard? So if you're wondering how fast these ocean currents flow, these kind of marine rivers, they might flow about 60 to 120 miles a day. So that's fairly fast for ocean water. But if you've ever seen Finding Nemo, a fairly good analogy of what it would be like to be in a shallow ocean current is when they're riding the East Australian current, when they're with the sea turtles, and they have to kind of like eject out of the East Australian current. That kind of gives you a visual if you've ever seen Finding Nemo. So that would be a good example. All right, so let's add a little bit more detail. If you are looking at any specific gyre, and in this case, we're looking at the North Atlantic Gyre and the Southern Atlantic Gyre, we've already noted the rotation pattern, so you should have noticed that it's rotating clockwise in the Northern Hemisphere and counterclockwise in the Southern Hemisphere. The other thing I want to point out here is that if you are on the western side of a gyre, so that would be this part of the Atlantic here, and this part of the Atlantic in the Southern Hemisphere, the water is warm. And the reason for that is because that's water that has come from the equator and either moved north or south. So western sides of oceans have warm water. If you were on the eastern sides of all of the oceans on Earth, they're going to have cold water. And the reason for that is because the water that they have has come from either the North Pole and flowed southward, so it's cold and it's going south, or it's come from the South Pole and it's flowing north. So eastern side of oceans, cold water coming from the poles. Western side of oceans, warm water coming from the equator. All right, so questions 3 and 4 on the quiz. Do you expect to find warm or cold water off the east coast of Australia, and why? And then do you expect to find warm or cold water off the coast of Chile or Peru, so on the western coast of South America, and why? So why do we get rotation? So we've already established that you have a clockwise rotation in the northern hemisphere, you have a counterclockwise rotation in the southern hemisphere. Just as an aside, if you've ever heard that toilets flush in the opposite direction in the southern hemisphere, that's where this comes from, but it's not true. Anyway, so why rotation? Rotation is caused by something called the Coriolis effect. So not all latitudes on Earth spin at the same speed. Some of them spin faster. So if you're at the equator is actually spinning each day about 1,025 miles per hour. Obviously, you don't feel it because you're used to it. Your body adapts to it. But if you were up at a northern latitude, for example, Earth might be spinning at that latitude at 515 miles per hour, so about half the speed. So if you try to launch an object from the equator to the North Pole, and you try to launch it, or you launch it straight, it's going to look like it's going to go off path. And the reason for that is because you have this difference in the speed that it is spinning. So what it would do is that if your intended path is straight, what it will do is it will actually curve to the right because of the way that it's spinning slower north or south of the equator. So usually this is best seen in a demonstration, which I don't have the ability to do. So what I'll have you do is that there's this video here, a link, and then I'll put the link on Blackboard, or the link is on Blackboard. So you're going to watch this video and then use that to explain how the Coriolis effect would relate to the pattern of ocean gyres. Lastly, here we're just going to talk about deep ocean circulation. So we were just talking about shallow ocean circulation, but now we'll talk about deep ocean circulation. So there's also circulation that occurs all the way at the bottom of the oceans. This is usually referred to as a conveyor belt form or pattern. The fancy sciencey word that we use for this is thermohaline circulation. So thermo means heat or temperature, and then haline means salt. So halite is table salt, just in mineral form. So that's where this comes from. So it basically means that you have temperature and salt that drive circulation. So if you recall from the last lecture, you were looking at maps of temperature and salinity. And at the end, I talked about how density of water is affected by both salinity and temperature. Cold, salty water is more dense, so it sinks. Warm, fresh water is less dense, so it will rise. Thermohaline circulation is driven by density. So there are certain locations around the globe where cold, salty water will sink down to the bottom. That's our blue here. It'll follow this kind of conveyor belt area, and then it'll heat up and become fresher. So it will rise up to the surface, warm water flowing on the surface, it will cool off again, sink back down, and you get this conveyor belt that distributes heat around the globe or around the ocean. This entire cycle takes about 1,000 years to complete. It controls our global climate, which we'll come back to next week. So it's immensely important, and it's being affected by climate change, which we will also talk about. Okay, so just to give you another visual of that, water can circulate about 1 to 2.5 miles deep or so, and then again, it connects all of the oceans here in terms of looking at how warm and cold water circulates around the globe. If you would like to see an animation, here's another link for you to look at if you want to. It'll show you an animation of a drop of water basically traveling around the global ocean conveyor belt. So to finish up your quiz, I want you to do a little bit of research about the importance of thermohaline circulation. So why should you care? And then why is thermohaline circulation important for Earth's climate? So is this being affected by climate change? So you can answer that question. And then we'll also talk about this or bring it back up in the final week of the course. But for now, your answer should be 3 to 4 sentences. And then that's the remainder of the quiz that you have for Lecture 2 in Oceans.